Okay, guys, let's go into part 3, electricity. All right, here I'm going to introduce to you a few more formulas. The first formula here, see, there's a different E here. Just now, the EMF was a different E. I wrote it differently. Now, in part 3, this we are going to call it as energy. Electric energy, energy used. All right, so this is electric energy. And very simple, you can remember as E equals to vitamin, VIT, vitamin, VIT, vitamin. V is voltage, I is current, T times seconds, must be second. Now, we also have learned that Q is equals to IT. Remember your first part 1? So Q equals to IT. So if I replace this Q with Q, it becomes Q. I can remember everyone is very cute, although it's not correct, it's C-U-T-E, but let's call it cute. Everyone is very cute, all right? Okay, so E equals to VQ, E equals to VIT. Good. Next formula which you must learn is power. Power is P, P equals to VI. How to remember in Malay, you can just call it as Punggong very itchy. Backside is very itchy, sorry for that. But anyway, we want to learn and remember it better, so therefore Punggong very itchy. It's quite nice, quite cute in Malay, all right? Okay. Good. So these are the 3 formulas we want to learn. Now, however, we have also learned that V equals to IR. You see that? That is Ohm's law. So if I were to take this formula, if I were to take this V equals to IR, can you see? So this is IR, take this, put it here. What do you get? Take this IR, put it inside the V. So you can also get IR times I, which is equals to I squared R. So this formula is also power, but generally is used for loss of power, especially due to heat, all right? So anytime there's a heat loss is normally caused by high current. When the current is very high, it causes a lot of heat. So therefore, this is very useful formula, P equals to I squared R for power loss due to as heat energy, all right? Now, let's take a look at this one. So V equals to IR again. So from here, what is I? Bring the R down. You get this, right? So now take this, VR, I is VR, take this, put it inside here. What are you going to get? What will you get? What will you get? Okay, so you are probably going to get, you will get P, I replace I, correct? So V over R. So our next formula which is possible is this. So 3 different formulas are useful. Whichever formula you can use according to what they give. So you just know that there are 3 formulas usable for power. Are you all right? Okay, good. So therefore we have now learned how many formulas? This is one formula. This is the second formula we learned. Then we have also learned the EMF formula, right? What's the EMF formula? EMF is V plus IR. So that's our third formula. Sorry, this is small r. Okay, third formula. Then we have the fourth, and then we have the 5th formulas. 5 formulas, we have it here. Are you all right? Okay, so now I'm going to take you into this. I'm going to take you into this diagram here, and let's solve some questions using all these formulas. Are you okay? All right, let's try. Okay, so I'm going to erase this stuff. Okay, let's erase all this since you already know. So make sure you write down this formula so that it becomes easy for us to work it out. All right, so first question now. All right, so I'm going to also erase this stuff. Okay, so now you're given that the the EMF is 12 volt. EMF is 12 volt. The internal resistance is 2. You're given this. What is the basic rule that they have learned? The basic rule we have learned in a parallel circuit. Still remember, parallel circuit, what is that? Each parallel branch will have the same voltage. Whatever voltage given here to here, same as here to here. Same. Okay, good. So the current will split accordingly. So let's use our first formula. No, but before that, let's calculate total resistance here. This is a series circuit, same line. So you can just add it up. So total here, total will be 6 plus 2 is 8 ohms. Are you okay? Good. Then this 2 is parallel. Parallel means we must use this formula. Which means here's 8. This total formula, total resistance. 6 plus 2 is already 8, so here also 8. So that's easy. So you get 2 over 8, which is 1 over 4. Please check. Okay. But remember, to find the total here, you must flip it over, flip. Therefore, what is R? R is 4 ohm. That means, in other words, this whole thing here now is become like one piece, and it's just 4 ohms. That means your diagram will look like this. This is now 4 ohms. Here we have 2 ohms internal resistance with 12 volt is our EMF. Can you see that? So that's how this diagram has changed to this. So why is this 4? Total. How you calculate? This plus this is already 8, direct. Then use parallel. Are you okay? So now we have got this. Let's use our EMF formula. What's our EMF formula? I erase this, okay? I erase this. So what's our EMF formula? Our EMF formula is this. I, okay, this is what? So our EMF total is 12. Our I is unknown, which is here, coming here. This is our I, the main I, current. The resistance for outside, what is R, big R? Big R stands for outside resistance. Outside resistance, external resistance, out of the battery, which we just found to be how much? 4. Internal resistance 2. Divide, what do you get? Which means the current which is flowing is going to be divide. So which means now the current which is flowing through the here, an ammeter is going to show 2 amperes. 12 divided by 6. Are you okay? Now we must find out, next step, how much voltage is lost here? How much voltage is lost? So the current flowing here, the resistance is 2. So voltage lost inside the battery. Formula is same, I times R. 2 times 2, 4. Which means 4 volt is used up in the battery. Now, if 4 volt is used up in the battery, total supply 12, but 4 has been used up, what's the balance? The balance is 8, which means 8 volt now is available for outside. So which means now what's the next concept here? Every branch which is parallel must receive the same amount, which means the balance 8, here to here 8 volt will be supplied. Here to here 8 volt will be supplied. That means A to B, AB will have 8 volt. PQ will also have 8 volt. Are you following me? You okay with that? All right, so I'm going to erase this stuff. Now your next task is you need to find out what is the current which is flowing in I1 and let's call this I2. What is the current in I1, I2? All right, so since here is 8 volt, so let's calculate V is equals to IR. Okay, so here voltage is 8. Current don't know, R is also 8. Which means divide. So the current which is flowing here will be 1 ampere. So here 1 ampere will be flowing. So if you are calculating for this, same thing, V equals to IR, total resistance is 8, current is here, the voltage supply is 8, why? Because the same amount must come here. So again, the current is 1 ampere. 1 ampere. Now let's calculate same, correct or not? Now here was 2 ampere. 2 ampere comes here, it split 1 ampere, 1 ampere. Why it split equally? Why? Normally it should not. It will only split equally if the amount of resistance is same. Here is 8, here also 8. Same resistance, resistor value. So same value, so that's why the current split equally into 1 ampere. Are you okay? All right. So therefore you must know this working. All right. So take a look, click, make sure. All right. So what I want you to do is after this video, copy this diagram again on a piece of paper, redo it in the same way, check whether you can get the same answer without looking at the video. All right. So now one more. Then last one before we finish the video is what is the energy? What is the energy here? So if I ask you how much energy has been used by this? How much energy? So the voltage supplied here is how much? 8 volts. So put in 8. This is AB, yeah? I'm doing at AB. The current moving is 1 ampere. Let's say energy used in 100 seconds. 100 seconds. So times 100. So times everything, you're going to get 800 joule. So 800 joule will be used here in 100 seconds if the current is 1 ampere. Are you okay? Now let's try one more. Somewhere, let's choose this. So over here, erase all this. Let's say now, what is the energy at this point in 100 seconds? Here only, don't want everything, here only at 2. So therefore, the problem is we don't know what's the voltage. The voltage for the whole thing is 8, but what's the voltage here? How do you find the voltage? How do you find the voltage? So let's check. So current flowing here is 1. So if I put a voltmeter here, the current which is flowing is 1. So V equals to IR. V equals to IR. So current which is flowing here is 1. The R is 2, which means 2 volt is given here. But the whole thing is 8. 2 volt is given here. So now you have found the volt, we can actually find what is the energy used. So the energy used here is, volt is 2, we just found. The current flowing is 1 ampere. Time is 100 seconds, which means the energy used will be 200 joule over here. Are you following me? All right? Okay. So in the same way, if I ask you how much power is lost at this point, power. Since we know the current, I can change this formula, no? What's the formula just now? I squared R. So since I know the current, which is 1 squared, what is the R? 6. Which means you times everything, you get 6 watt. So 6 watt is lost at this as the power, or power used is 6 watt. I hope you're okay. So this is part 3. With this, the electricity chapter is more or less covered. About 80 to 90% I have covered. The rest you read it up, all right? Okay. So following videos on physics, I will go into electromagnetic force, which is the next chapter. So take note, make sure you master this, do a lot of practices. Are you okay? Now, one more thing is this thing will always come out in your paper 3 SPM, paper 3. That means they will ask you to find what is the internal resistance of this circuit. So this is one of the most popular questions in this chapter for experiment question paper 3. Are you okay? All right, thank you guys. See you soon. I'll wait for my maths and biology videos soon. Thank you. Bye.